Assalamualaikum and hi everyone. So today I want to discuss about dimension in the first chapter, which is physical quantities and measurement. So this is the overview of the chapter 1. But in this hour, we just discuss about the dimension. So what is the learning outcome of the dimension? Define the dimension and then determine the dimension of derived quantities and then verify the homogeneity of equation using dimensional analysis. Okay. So what is a dimension? Dimension is defined as a technique or method which the physical quantity can be expressed in the terms of combination of the basic quantities. So it can be written as a physical quantity or its symbol. So the table shows the dimension of the basic quantity. So all these basic quantity you must remember. Let's say we have the basic quantity shown in the table. We have 1, 2, 3, 4, 5, 6. So all these basic quantity you must remember and you must memorize. So for example, the dimension of the mass, you must put it by using the bracket, or you can using the symbol of the mass. And the symbol of the dimension is capital M and unit of the mass is kilogram. How about length? You must put the bracket, okay, for the length, or you can use the symbol of the length and must put the bracket, and the symbol for the dimension is capital L and the unit of length is meter. And the next one is time. You must put it in bracket, okay, and you put it time, or you can put the symbol of time is small t, so put in bracket. The bracket here mean we want to do the dimension of that quantity. So the symbol of the symbol of the dimension of the time is capital T, and unit of time taken is second. And then next one is electric current. You can put in word, or you can use the symbol of the electric current is capital I, then must put in bracket. So the symbol of the electric current you can put A or I, and the unit of electric current is ampere, capital A. And then the temperature you can put by using the word, but must put in bracket, or you can use the symbol of the temperature is capital T. So to do the dimension you must put it bracket. And then the symbol of the dimension is theta and unit is Kelvin. Lastly, amount of the substance, or you can put a capital N, must put in bracket. So the symbol of the dimension is capital N and the unit is mole. Example just now is mass. So mass, you must do the dimension. So the dimension you must put in bracket, so equal to, and the symbol of the dimension is for mass is capital M. Okay, the length, so you must put it capital L. Time taken, so you must put it capital T. So dimension can be treated as algebraic quantities through the procedure called dimensional analysis. Okay, the uses of the dimensional analysis are: determine the unit of the physical quantity. To determine the unit of the physical quantity, next one is to determine whether a physical equation is dimensionally correct or not by using the principle of homogeneity. By using by proof the dimension on the left hand side is equal to dimension of the right hand side. To derive or construct a physical quantity. To derive or construct a physical equation. Sorry. Okay, note here, dimension of dimensionless constant is 1. Okay, if you have a number, let's say 2/9. Okay, so dimension of the dimensionless constant is equal to 1. So the dimension of 2 is equal to 1. Or another example is for the refractive index. The refractive index that we know, it just have a number. So its dimension is equal to 1. Dimension cannot be added or subtracted. And then the validity of an equation cannot be determined by dimensional analysis. The validity of equation can be only determined by experiment. So we go for the example 1.1. Determine a dimension and SI unit for the following quantities: velocity and acceleration. So first step, you must write down the equation of the velocity. Okay. Before this, I already explained that you can use the equation by using the word, or you can write down the equation. So first, if you want to write down by using a word, so you must know the equation of the velocity. So the velocity, we want to do the dimension, so must put in bracket velocity, and then bracket to do the dimension of change in displacement over the time interval. Or if you don't want to use the word, you can use the symbol. If you already know the symbol of the velocity is V, so you can put bracket V. So bracket, the change in displacement is delta S. So you can just can write its symbol, so over delta T. So you must put all these quantity with bracket if you want to do the dimension. Okay, and then the dimension of the dimension of V. So now you want to find the dimension of S. The dimension of S, you must identify. The displacement is we measure. We use to measure a length. So you must use dimension of length. So dimension of length is capital L. Okay, and the delta T just now is the time taken. So symbol for the dimension of the time taken is capital T. So we combine this L over T, become L T power of -1. This is the dimension of the velocity. And the SI unit you can get from this dimension. So refer back, the L is referred to length, so length is unit meter, and T is for second, and T for the time taken. So time taken we refer to unit second, small s, so meter per second. Next one is acceleration. So if you already know the symbol of the acceleration, you can just use the symbol. So let's say here the acceleration small a. We want to do the dimension, so you must put all the bracket, and then over change in the velocity, over put in a bracket change in the time taken. Okay, so in question A, we already done the dimension of the V. So we just put the answer here. So the dimension of the V is L per T, and then the delta t is time taken, so the symbol of this dimension is capital T. So we combine this, it become dimension of A is L per T square. So how about the SI unit? So from here, L is referred to meter, length referred to meter, T refer to time taken, so time taken is second. So we get the unit of the expression is meter per second square. Next learning outcome for the dimension is verify the homogeneity of the equation using dimensional analysis. So let's say the example here, determine whether the following expression are dimensionally correct or not. Okay, give you the equation here, 2s equal to 2ut plus at square. And then you must read up until the final equations. So given the S, U, A and T represent the displacement, X the displacement, U is the initial velocity, A is acceleration, and the time taken, the small t is time taken of an object respectively. So first of all, to solving this one, you must start with the left hand side. The left hand side is 2s, so you must put it bracket 2s, and then you do the separately for the each quantity. So 2 is dimensionless, so 2 is equal to 1. Dimension of the 2 is equal to 1, and then the dimension of s displacement is capital L. Okay, next one, you do the dimension on the right hand side. So for the right hand side, just now we have 2ut. So you do it separately, 2u and the t. Okay, so the dimension of the dimension of the constant is 1. And then we already done on the previous example, the dimension of the u is lt power of -1, and the time taken is t. The dimension of the time taken is t, so we cancel this one, it become L. The dimension of 2ut is L. Okay, we have another equation, and at square we must do separately for the equation that have added just now 2ut plus at square, so we must do it separately. So at square, do it separately, the a and the t square, and we already done it on the previous example. So the a is L per t square, and then for the time taken, t square, so capital T square. So if you can see here, we can cancel, so it become L. So if you see here, the left hand side is L, the right hand side for this equation 2ut is L2, and at square also L. So we can conclude that dimension on the left hand side is equal to dimension on the right hand side. So we call this equation is homogeneous or dimensionally correct. Okay, example 1.3. Show that the equation below is dimensionally correct. Okay, by using the equation of Q equal to pi r power of 4 P1 minus P2 over 8 eta L. So you must refer the symbol, what is meant by each symbol. R is inside radius, length is the length, P1 minus P2 is the pressure. Eta is the coefficient of viscosity, and it provides us with the unit Newton second per meter square, and the Q is the volume rate of flow, meter cube per second. So how we solve to to show this equation is dimensionally correct? So we must do part by part, which is for the left hand side first, and then right hand side. Okay, so we go for the left hand side. Okay, the left hand side, Q, and the Q provide with the unit, which is m cube as -1. So the dimension of Q, you must put bracket, so equal to m refer to capital L, so L cube. The S refer to T, per T. So the left hand side, the dimension of the left hand side is L cube per T. Okay, now we must do the right hand side. Okay, the right hand side we have pi r power of 4 P1 minus P2 over 8 eta L. So we want to do the dimension. So do the dimension separately. Pi r 4 bracket P1 P2, okay, over 8 coefficient of viscosity, okay, and then L. Okay, so the R we refer to L, the length we refer to dimension of the length, and then pressure we must find the dimension it first, and also the coefficient of viscosity. Okay, so start with the right hand side. Okay, we want to find the dimension of pressure. So pressure, put it bracket, F over A, area, force over area. And we know that the force is mass times with the acceleration over the area is length times with length. Okay. And then mean that the mass, we use it capital M, the dimension of mass is capital M. Acceleration we already done on previous example. If you don't know the dimension, you must do part by part lah. Try solve for the acceleration, but now I already have the dimension, I just use it. So LT -2 over, okay, length is, the dimension of length is L square. So we solve this, it become M L -1 T -2. Okay, next one, we must solve the coefficient of viscosity. Already have the unit Newton second M -2. But the problem here, this one is Newton. Newton is not SI unit using the basic quantity. So we must convert this unit to basic quantity. So Newton is refer to unit force, which is force force equal to MA, so the unit is kg ms negative 2. So we combine this, it become kg ms negative 2 s m negative 2. So it become kg m negative 1 s negative 1. So now we can do the dimension of eta. So equal to kilogram is referred to capital M refer to length, so L, and S refer to second, so T negative 1. Okay, so we already done for the dimension of the coefficient of viscosity. Now we want to do dimension of the okay, done. So we continue here. So the pi is a number, so it's dimensionless, the value is 1. R refer to the length, so L power of 4. And then to solve P1 minus P2, the dimension of P1 equal to dimension of P2, so equal to dimension of P. So we will use this dimension. So ML negative 1, sorry, T negative 2, okay, over 8 is 1, and the eta is ML negative 1, T negative 1, and the length is length. So we solve this. L cancel. L here. So it become L power of 3 T minus 1. Okay, if you can see here, the dimension of the left hand side just now, L power of 3 per T, is equal to the dimension of right hand side, which is L power of 3 per T. The dimension of left hand side equal to the dimension of right hand side. So we can conclude that the equation is dimensionally correct.